What if you have a body-centered cubic? What's your packing efficiency? If you did this, you'll find that the packing efficiency is 68%. Why is that? Imagine this, remember you have an atom in the middle here, right? And you got an atom at each corner, right? So you got these three atoms. So this is the atom in the center, okay? And this is in the corner, and this is at the corner, okay? Using Pythagorean theorem, okay? If this side here is A and this side here is A squared plus A squared would give you the hypotenuse squared, right? So A squared plus A squared equals what? The length of this diagonal, right? So it's going to be 2A squared. So this thing right here then is square root of 2 times A. So this length right here, square root of 2 times A. A squared plus A squared is equal to 2A squared. And then if you use this one right here, look at this right triangle right here. This is square root of 2 over A. This is A. Square root of 2A, I'm sorry. And so this length right here, the diagonal across the cube would have a length of square root of 3A. Okay? So that means that, let's look at the length of the diagonal. You have three atoms across the diagonal, right? So this is one corner and this is the other corner. Well, that's the radius of one atom. That's the radius of the second atom. That's the radius of the second atom. That's the radius of the third atom. So that's 4r right there across the diagonal. So that 4r is square root of 3a. Okay, this is square root of 3 times a. So 4r is square root of 3 times a. So what is a? Solve for a. A is equal to 4r over square root of 3. Okay, so how do we determine the packing efficiency? The volume of the cube divided by, the volume of the sphere divided by the volume of the cube. But how many spheres do we have in a body-centered cubic? 2. 1/8 of the 8 corners, right? Plus the one in the middle. So your packing efficiency is the volume of 2 spheres. So 2 times pi, what's the volume of a sphere? 4/3 pi r cubed divided by, what's the volume of the sphere? A cubed, which is 4r over square root of 3 cubed. So your packing efficiency is how much? That's going to be 2 times 4, so that's 8. 8 pi over 3 in the numerator times r cubed. In the denominator, you're going to have, what's 4 cubed? 4 times 4 times 4, 64. 64 r cubed over, what is square root of 3 cubed? Square root of 3 cubed. That's square root of 3 times square root of 3 times square root of 3. That's square root of 3 times square root of 3, right? And so cancel your r cubed, and let's see if we get 68%. That's going to be what? 8 pi over, okay, times 3 square root of 3 over 3 times 64, right? Is that correct? So 3 cancels out, 8 and 64, that leaves you with 8. So that's square root of 3 times pi over 8. So pi times square root of 3. What's the square root of 3? Raised to the power 2 divided by 8, 68%, 0.68. Okay? So you're looking at 68% packing efficiency. In other words, you get more, okay? More of that volume of the cube is occupied by the particles of your solid. Whereas in a simple cubic, what was our packing efficiency, you remember? 52%, this one is 68%.